the third set that we did, Discrete Random Variables, Chapter 7. So to begin with, we'll do an analysis of the content, and then we'll get into the questions that I've grouped together. So 7a, we talk about what are random variables, what do we mean by that? So we're using capital X to denote some random variable, right? And we've looked at both sort of binomial distributions and normal distributions. So we've looked at two types. We've got continuous, things that we measure, and we've got discrete, things that we count. And in Chapter 7, we're talking specifically about distributions that involve counting. Okay, so we're talking about discrete distributions. In 7b there, we've got the discrete probability distributions. Okay, so notice, here's a key difference, right? Discrete probability distributions, these are like whole integer values. Whereas if you think of a continuous random variable, whether it be a normal distribution or a probability density function, it's taking place over an interval, right? There's no gaps in between. So there's a key difference. Okay, we're talking about exact events occurring. We got some information about that. In 7c, we have the mean of a probability distribution, okay, or E of x, the sum of each value times its respective probability. 7c3, we've got application of that with fair games. In 7d, we have variance and standard deviation, how to calculate those for probability distribution. In 7e, we have properties of ax plus b. So if we have some random variable x, and it's got a relationship, a linear relationship to some variable y, then we can figure out the properties of y. Bernoulli distribution, which is where we have one trial, and we've got two outcomes, very clearly denoted, success or failure. And then 7g.1, we look at the binomial distribution. 7g.2, technology calculations for the binomial. And 7g3, mean and standard deviation. Okay, so let's get straight into the question. We've got here a policeman is inspecting the safety of tyres on cars passing through some checkpoint. The number of tyres which need replacing on each car follows the probability distribution alongside. So some cars need 0. In fact, most of the cars need 0, right? We've got 0.68 cars need no tyres replacing. 0.2 need one tyre. 0.06 need two tyres. This is K, and this is 0.02. Here we have X, here we have. So just describe that notation. These are the possible events, right? Lowercase x, the possible events. And then here in this way we have the probability that the random variable, the observation that we're making, takes on the event, lowercase x. All right, so the first one says find the value of k. Well, all these probabilities have to add to 1. So k is just going to be 1, take away each of these probabilities, right? 1 take 0.68, take 0.2, take 0.06, take 0.02. And where we got 0.02. K is 0.04. Alright, find the mode of the distribution. Now the mode for a probability distribution is the event that has the highest probability. So if we look along, where's the highest probability? It's here. So we're not writing the probability, we're going to write the event that corresponds with that, and the event is 0. Alright, the random variable will be 0 for the mode. Alright, and then for C, find the probability of x greater than 1 and interpret. So x greater than 1, that's going to be these events, right? These events here. Has to be larger than 1. So this is important where we consider the difference between greater than and greater than or equal to. So we don't have the line underneath, which means we're just talking about larger than 1. So we're going to add these probabilities together and we'll get 0.12. Okay. And so this is the probability that a car will need 2 or more tyres changed. More than 1, 2 or more tyres changed. Let's answer that. Excellent. Okay, we'll move on to question 2. We've got when Ernie goes fishing, he either catches 0, 1, 2, or 3 fish, and the probabilities are shown alongside. On average, how many fish would you expect Ernie to catch per trip? So, 0, 1, 2, 3, and the respective probabilities. 0.36, 0.19. So for expected value, all right, the expected value, the mean, the average of a distribution is each event multiplied by its probability added together, right? Okay, so you can put that in your run mat. The other way we can do it is in our statistics mode. We can have list 1, list 2, and as long as we've got the correct setting, it will generate the observed value for us. So I'll calculate that quickly. 7.286. 1.57. Okay, so on average, each trip that he goes fishing, he catches 1.57 fish. Excellent. Okay, number 3. Calculate the mean, median, mode, and standard deviation for this distribution. All right, so the mode is the event that has the highest probability, corresponds with x is 2. The median is the event that corresponds with the cumulative probability reaching or exceeding 0.5. So we look here, we've got 0.3, and we move along, we add those probabilities together, we get 0.7, which has exceeded 0.5. So the median is also 2. And then the mean is the events, right? Each event times the probability. And standard deviation. So let's flick back into a standard deviation calculation manually. We've got the sum of, I'll write the formula. So we're going to do the sum of each event squared times its probability, and then we'll take away the mean squared. And of course, the simplest way to obtain the standard deviation, right, is list 1, list 2, calculate the first variance, get the statistical information. That's going to tell us all of that as well. But if we need to do it manually, or if we need to show what it is, this is a good formula we can use. So let's write that out. So it's the square root of equal value squared. So 1 squared times the probability plus 2 squared times the probability plus 3 squared times the probability. Alright, so the sum of those, and then take away the mean squared at the end. That's what we'll calculate. 0.775. Cool. Excellent. So that's question 3. I'll rub the board and move on to number 4. Answer all the components of it. We'll just answer probably the first one from each because there's a few there. So we've got Dominic is a door-to-door salesman, and each day he earns $100 plus 25 for each sale he makes. And from previous experience, he knows that the number of sales made per day follows the distribution below. So here's his distribution, right? So these are the number of sales he'll make. 3, 4, 5. And here's the probabilities of them occurring. 0.15. Okay, part A, find E of X. So here we can just put that straight in our calculator, list 1 and list 2, and generate the probability of 1.85. E of X is 1.85. Alright, part A, find E of X. There's some other things there for us to find, but we'll just leave that. Part B, suppose Y is the amount of money he makes per day. Alright, so X is the number of E of X, this is the number of sales. On average, he makes 1.85 sales per day. Here it says, suppose Y is the amount of money he earns in dollars per day. Write Y in terms of X. Well, he's going to earn $100 per day plus $25 for each sale that he makes. Okay, where X is the number of sales that he's made. So that's our answer to part C. And then we'll answer C part 1. Hence, find E of Y. So this is a relationship between the variable Y and the variable EX. Okay, X is how many sales are made. Y is how much money is made. Y is proportional to X, right? Okay, so E of Y is equal to E of AX plus B. So this is on the formula on the other side, E of X plus B, which is A times E of X plus B, which in our circumstance is going to be 25 times, what was the value of E of X? 1.85, and then plus 100. So you get, when you mash that, 147, yeah, 146.25. Okay, so that's what that exercise is pointing out, the link between two variables, and that we can arrive at the properties of variable Y using with an analysis of the variable X. Splendid. On to number 5. Here we have a spinner. Let X equal 1 if the outcome is red. Okay, so in our circumstance it's black, not red. If X equals red, and X equals 0 if the outcome is white. Part A, explain why this is a Bernoulli random variable. One trial, okay? So there's 2 conditions for a Bernoulli experiment. One trial, and the other one is we have very clearly stated success or failure. One trial, 2 outcomes, success or failure, correspond with results 1, 0. So they're the two contingencies we need to satisfy for a Bernoulli distribution. One trial, and then we've very clearly stated the parameters of the experiment. What's success, what constitutes failure. Okay, part B, find the mean of the X. So the mean of a Bernoulli distribution is P. And P is the probability of the success. That's the event that corresponds with X equals 1. And so that's when we get a red, that's a success. So the mean is 3 on 4. The standard deviation is the square root of PQ, which is going to be the square root of 3 on 4 times 1 on 4, which is root 3 on 16. Okay, very good. 40. Records show that 6% of items assembled on a production line are faulty. A random sample of 12 items is selected with replacement. Find the probability that A, none will be faulty. So here's a binomial distribution question, right? And they're saying, what's the probability that the random variable is equal to 0. That's an exact event. So let's revise 2 ways that we could analyse that. BPD, all right, we're talking about 0 successes out of 12 trials, and the probability of a success is a faulty item, is 0.06. Okay, so that's one way we can calculate it. The other way is with binomial distribution formula, okay, which is we have 12 trials, 0 successes. The probability of success, so the number of successes, times the probability of failure, to the number of failures. Okay, both of those are going to generate the same solution. Using your calculator with that syntax, we've got 0.4759, so 0.476. So where does it pop up in the exam? So it won't matter which process you do, but it's important to know this because I have seen in the past this notation and it says like interpreter. What does it mean? Calculator and interpreter. But we did do that when we did that pretty thoroughly when we were going over the practice tests. Okay, part B. How about at most 1 will be faulty? At most 1. At most 1. So if you think how many of these items can be faulty, there's a long list, right? It goes from 0, 1, all the way up to 12. Okay? And they've said at most 1 is faulty. That means this event, 0 or 1. At most 1. Anything less than 1. So this is the probability of x being less than or equal to 1. Alright? So there's 2 ways we can calculate this. Okay? One way to think about what is, it's a BCD calculation, let's do that one first. And we're saying between 0 and 1. Alright, between 0 and 1 being faulty, out of 12 trials, and the probability of it being faulty, 0.06. So I'll calculate that first, and then I'll explain the other way of thinking of it. 0.840. Alright, the other way to think of this is, what does event 1 mean? Well, we've got 2 events that we're going to add together, isn't it? It's the probability of event 0 plus the probability of event 1. So if you calculate both of those probabilities and add it together, it's going to be the same as this calculation. You've already done that one. That's what this was. Probability of x is 0 is 0.476. So if you were to calculate that discrete event and add them together, then you would get that number. So either of those is fine. But this is what BCD means, right? Cumulative distribution. It's the sum of individual events occurring. Okay? Next one. At least 2 will be faulty. If we've got at least 2, it means 2 or more. Now we're talking about this event. Okay. Again, 2 ways we can perform this. We can go, all right, BCD between 2 and 12 out of 12, 0.06. Yep, we can do that. Or we know that this event here is 0.84. So this event from here onwards has to be 0.16. The sum of all probabilities adds to 1. So we know that that will evaluate to 0.16. So we can think about these things like that. Okay, and then part D, less than 4. Alright, so this is where notation is important. 2, 3, 4, 5. It says less than 4, it means not inclusive, right? Less than 4 means BCD between 0 and 3. When we do the BCD calculation, it is inclusive of the upper and lower boundary, those parameters, between 0 and 3 out of 12.06. Alright, so there's a pretty reasonable summary of chapter 7, the content that we did there. So I really encourage you to have a look at the revision guides, right? So they're floating around, you've got your electronic copy. So if we like just flick open to it, okay, so you know they've got all, they've condensed a lot of information in there for you to have a read of. And then there's general questions, right? And the general questions, it combines them, but it's pretty clear where they're split. So the first ones are all about discrete, okay? So I can see from question 1 onwards, they're discrete distributions, all right? Keep going until you get to about question, we've got Bernoulli's there, we've got X, continuous random variable, about question 18. 17. Yeah, so if you just go up to question 15, you'd be able to answer those general questions there from the revision guide. So it's up to you where you direct your efforts, okay? I'm encouraging textbook, I'm encouraging revision guide, but you know, you've got plenty of things to work on, so up to you. Cool.